Dear students, next important point is advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. So this advanced sunrise and delayed sunset is also another important optical phenomenon related to the atmospheric refraction. For that you just consider Earth. Just imagine that it is Earth. Okay. So it is the horizon. It is called horizon. Okay. Just imagine sun is located here. Sun. Okay. So advanced sunrise and delayed sunset. That means we can see the sun 2 minutes before the actual sunrise and 2 minutes after the actual sunset. That is called advanced sunrise and delayed sunset. So here again, this phenomenon is due to the process or the important point, that is atmospheric refraction. Atmospheric refraction. Okay, so how it is happening? So this is what we call horizon. Clear? And before sunrise, the sun is located just below the horizon. But we are seeing the sun 2 minutes before the actual sunrise. Because at the time of sunrise and sunset, the sun is just near to the horizon. Right? So the light rays are traveling through the different atmospheric layers having different optical densities. And also, near the sun, the atmospheric layers are warmer or hotter region, means optically rarer region. While moving from that region towards Earth, the optical density is increasing, or near this Earth surface, the atmosphere is optically denser, which means the denser air which refracts the light more, or while moving from the optically rarer region to the optically denser region, the rays refracts downwards, means bending downwards. So if a person is observing from this position X, he or she is observing from this position X, he or she happened to see that the sun is just above the horizon, but actually the sun is just below the horizon. Clear? Once again I will say, we can see the sun before 2 minutes of the actual sunrise and 2 minutes after the actual sunset. It is because of the phenomenon atmospheric refraction. Okay, we know that the atmosphere consists of different air layers. Each layer has its own optical density because of the variation of temperature. So when the light is passing through all these media, or the light is entering from one medium to another medium or through different media, as a result, the refraction of light takes place in the atmosphere. That is called atmospheric refraction. So because of this atmospheric refraction, the sun appears just above the horizon. Why? The rays are coming from the sun like this. Just to consider some rays. So just near the sun, the atmosphere is optically rarer medium. While moving from that position, one by one, the atmosphere which becomes optically denser. So when this light is passing through or traveling through the atmosphere layers having different optical density, because of the variation of the optical density, the light bend downwards. So the person those are observing from this position X, he or she just happened to see that the sun is just raised above the horizon. That is the reason why we are seeing that the sun is just above the horizon or 2 minutes before the actual sunrise. The same atmospheric refraction is the reason behind why the sun is appearing even after the actual sunset. Clear? So it's all these things are because of the atmospheric refraction. Another important point is that sun's disk means the shape. At the time of sunset and sunrise, we know that the sun is just near to the horizon, right? So the light refraction takes place in the atmosphere, but at different amounts, or the refraction of light takes place unequally. Means refraction takes place in different angles or different ways. They are not equal. Unequal atmospheric refraction takes place in the case of the sunrise and sunset. At that time, the sun is just near to the horizon. So, the light rays coming from the sun traveling through different atmospheric layers and refracting at different angles or refracting unequally. As a result, the sun is appear to be flattened shape or oval shape at the time of sunset and sunrise. But at noon time, the sun is just above, means sun is above, overhead, right? Exactly at this position or overhead. Sun is at overhead. And at this position, almost all the rays are passing through the atmospheric layers normally. Therefore, at noon time, the sun appears circular in shape, exactly circular in shape. So, at the time of sunrise and sunset, the sun appears oval shape or flattened shape, but at the time of noon time, the sun is overhead. Therefore, the refraction that takes place normally means the light rays are passing through the different atmospheric layers normally. Therefore, at that time, sun it looks like a circular shape. Clear? So, these are the points about the advanced sunrise and delayed sunset. So, one more point is that in this case, we can see the sun 2 minutes before the actual sunrise and 2 minutes before after the actual sunset. So, the time from sunrise to sunset is lengthened to 4 minutes because of the atmospheric refraction. Clear? So, these are the important points. You should remember the same. And next time we meet with another topic. Till then,